Hello everybody, and in this particular video we're going to look at two of the operations that you can do on sets. So when I say an operation, we think of an operation in math as, like a addition, subtraction, things like that. It's combining two things in some way. And that's what we're going to be talking about with sets. And there are two major things that you can look at. The first of which is this upside down looking N that you see right here. And you remember that we're going to use capital letters to name our sets. This is what we call an intersection. Okay? And an intersection is the set of items that you can create from two or more sets. And these are the elements that are in both sets. Okay, so for example, let's say that I had the set A and it had just the elements 1, 2, and 3 in it. And then I have set B, and B has the elements 2, 3, and 4. Well, if I'm looking for you to tell me what the intersection of A and B is, I'm looking for you to tell me the things that are in both sets for sure. And if you look carefully enough, you'll notice that 2 and 3, those are the elements that are in both sets. So they are in what is called the intersection. Now, this is going to be kind of a silly explanation, but I want you to think about this for just a moment. I want you to think about the intersection of two roads. And I know this is a rather crude drawing. And the example that I like to use is, this is University Avenue right here, and then this is LA Grant Parkway here. And if we're talking about the intersection, then I'm talking about the pavement that belongs to both streets. And where they cross, that's where they're going to have the intersection. And I think that kind of helps to kind of drive the point home on what's what here. This other particular operation with the U is called a union. And that is a list of elements in either set. Okay? So it's not a list of elements that is in one and it's got to be in the other. It can be in either one of them. So if I wanted to find the union of A and B, then I have to list out all of the elements that are in either A or B or both. Now, if they're in both, I'm certainly not going to list them twice. I'm just going to list them once. And those elements that are in A and B are, of course, 1, 2, 3, and 4. So a couple of things to think about with intersections and unions is that unions are typically larger sets. Think if I took the union of all that pavement that is on both University Avenue and LA Grant, I'd get the whole thing. I'd have to kind of shade in the whole thing here with my highlighter to get the union. But if I just want the intersection, then I want the part that's on both roads, and that would be just what's right in the middle that I've already shaded here. So by rule, I guess you could say that intersections are typically smaller. And sometimes intersections could even be empty, as far as we know. So that's something to think about. Let's take a look at some practice problems here and look and see how that's going to work. And as we consider these problems here, let's start out with this idea of a universal set being the numbers 1 through 12. And remember what we talked about in the previous video, a universal set is going to be the set of all elements for a given situation. A is going to be the odd numbers that are in U. B is going to be 3, 6, 9, 12. Those are what are called multiples of 3. And that's what happens when you take 3 and you multiply it by consecutive numbers there. And then 1, 2, 3, 4, 5, the combination to the air shield. If you remember Spaceballs, that's going to be our set C. All right, so let's talk about finding the union of A and B. Now remember, this is what happens when we take all of A and add in all of B. So it's probably not a bad plan maybe to write that out off to the side here. All of A and add in B, but no repeats are needed. Okay, so what's in A, of course, is the odd numbers. I've got a couple of odd numbers that are already in B, but I'm going to add on 6 and 12 because those are the numbers that I have to add on. So 1, 3, 5, 6, 7, 9, 11, and 12. That makes up the union of A and B. Okay. All right. Now, what I'm looking for in the next one is in the intersection of A and C. So we might have to remember that they have to be in both A and C. So if I'm trying to find the intersection between A and C, I want the numbers that are in both sets. Well, as I look here, I've got odd numbers only in A, and I do have a mix of odd and even. So I guess all I need to do is look at the smaller set and notice that 1, 3, and 5, they are in both A and C. So those are the items that must be in the intersection. Just like that. All right, back on to part C here, and you notice that this is A's complement. Okay, so when we go to find A's complement, we're interested in, if you remember, the things that are in our universal set that are not in A. Okay, so this is the stuff that is in U but not in A. So if that's the case, and A contains all the odd numbers, then what isn't in A must be the even numbers, and those won't take a whole lot of time to list out. All right, now the last two examples here, they get kind of complicated because we've got a lot going on. So we need to kind of follow the order of operations here. Dear old Aunt Sally wasn't fooling around. She wants us to make sure that we have our operations correct. So what do I need to do on part D? Well, I need to think about the union of A and B first. And then once I find that union, then I need to find the complement of whatever that result is. So here's what I would do. Find the union first, then do the complement. Okay, so when it comes to finding the union, lucky for us, we've already done that. That's up here in part A. We've already found what the union was. So now, to find the complement of this union, I need to think about all the numbers that are in U that are not in this set right here. So if 1 is in the set, then it can't be in the complement. 2 is definitely in there, in the complement of the union. So is 4. You could probably make the case that 8 and 10 are in there as well. So 2, 4, 8, and 10 are what are in the complement of the union. Okay, and now we've got a real complicated situation here next. This is where we take the union of A and B, and then we have to intersect it with C's complement. So here's what I would do first. I would find C complement, then the intersection. Now the reason I say that is because, once again, we already know what the union is. It's right up here from part A. So I need to consider what C's complement is, and C's complement is going to be all of the numbers that go from 6 to 12, because C contains the numbers from 1 to 5, so the complement must be everything that's above 5. All right, so the last thing I need to consider is what is in both the union and also the complement. And the answer to that question is going to be this. 6 is in both the union and the complement. So is 7, and so is 9, and so is 11, and so is 12. If you need to run this back again and watch it one more time, by all means, please do so. But it's a bit of a challenge to try to pick off what that is. Okay, so that's a quick little tutorial on how to find unions and complements, and especially when things get a little bit more intriguing. Enjoy.